Hi, we have the AP Physics 1 past paper 2018. We are discussing free response question section. Now we have the question number 4 of the paper which carry the 7 points. In this question, a transfer wave traveling to the right to the string as shown in a fig. The two dots have been painted on a string. One is P and the other is Q. So the figure below shows the string at the instant in time. The instant shown, the P dot is at the maximum displacement in this case, and the Q dot is the zero displacement at this point. Okay. At each dot, P and Q drawn by an arrow indicating the direction of instantaneous velocity. So at that moment, what is the velocity of the point P and the Q dot P and the Q? If either dot had the zero velocity, write V0 next to the dot. This carried 2 points. Okay, first we discuss the P point dot P as the maximum displacement in SHM, so velocity is 0. So I have write V is equal to 0 in the fig. Now explanation, what you have to thought, the particle at the string is at crust or trough mean maximum displacement. It is not going to more further. So at that moment it is momentarily rest, instantaneous velocity 0 because it has to change the direction now. It has to go moving down or vice versa. Now it has to move toward the equilibrium. So at maximum displacement, it has to stop to return to the equilibrium. So that's why the velocity of the point at this point is 0. And what about the Q? Q is at the equilibrium line. It's the zero displacement. Speed is the maximum. So velocity is not 0 there. I have indicated the arrow with the upward ahead velocity. And now why upward, why not downward? This explanation. Q is at the equilibrium. One part of the wave is sloping down. You can see it has a negative slope in this case. And the string going down to right Q where Q sits. Now equilibrium position to the right side of the crust will be moving up. Mean as the wave passes, there the crust is left coming down while the remaining part, lower part is moving up. In simple case, you can understand this thing like this part of the wave is going now down and this part of the wave is moving up because the at it is trough, it is going to crust. Now this part is going to be the crust. So at this point, the Q will be moving upward as we indicate in the text. Next part of the question is the figure show the string is same instant at a point. At each dot P and Q, draw the arrow indicating the instantaneous acceleration. In previous case, we are discussing velocity. Now, in this case, we are discussing acceleration. If the dot has zero acceleration, write A0 next to the dot. So, first of all, in simple harmonic motion, acceleration is always directed toward the equilibrium position. For in case of dot P, because P is at the maximum displacement, the equilibrium point is above the point P, so acceleration is pointed upward, pulling the particle toward the center as we discussed before. Q point is at the equilibrium line, so restoring force is 0, so net acceleration is 0. I have written the A0 next to the Q. That's the answer. Now, the figure below represents the string at t is equal to the 0 same instant at part A. The dot P is at the maximum displacement from the equilibrium. Simplicity Q is not shown. Okay. The question is on a grid below string at t is equal to t by 4 where t is the period of the wave. On your drawing above, now draw the dot, indicate the position of P at the string is t by 4. Clearly label the dot with letter P. Now we have the two questions. One as well is draw the waveform after t by 4 time and indicating the P dot after t by 4. So both can be shown in the same fig. As you have to understand that this part, let's see, this is a screenshot. If this wave of the part has to move out of the screenshot and this part of the wave has to move in the screenshot. So t by 4, as we indicate, this is a time period. 1/4 is showing that t by 4. In t by 4, this wave move and this wave in. So this wave has to move at this point. So this is the point. So from this point, you can see P is there. Though because the P is on this line, and so P is at the equilibrium position in this case. In simplicity, you can say that the P point from equilibrium to the mean position. As we indicate in the previous case that it has the acceleration toward the mean position. Now, when the wave travel, the particle will move toward the mean position. So, in both those scenarios, you can understand that the wave is traveling toward the right, so that part of the wave will travel to this point, so the P point will move toward mean position. Now, part C. Now consider the wave at the t is equal to 0. Determine the distance travel. Total distance travel is asking not the displacement by the dot P in time t0 to t. The dot start at the top when displacement is minus 8 centimeter from the fig, and now we have to complete the path to return the same. So at t is equal to t by 4, it is at the trough, y is equal to minus 8 to the equilibrium. So total distance is equal to 8 centimeter. From t by 4 to t by 2, it is equilibrium to the peak. Again, the distance is 8 centimeter. From peak to equilibrium, then it is again the distance 8 centimeter. From equilibrium to the trough, again the distance is 8 centimeter. So it is going up and up, then move and then down. So there is a four part of the in time period. We have divided in time period into four parts. Each part it cover 8 centimeter. So there is a 4a is the total distance it travel a wave in time period. For amplitude, you can say 4 time amplitude. So amplitude is 8 centimeter. So that is the 32 centimeter is the answer. So that's the answer. If you have any query, kindly ask in a comment. If you like the content, kindly subscribe the channel and share with your friends. Okay, take care.